tell you, there's nothing like it. Rock and roll.
Must have been about 17.
Here it comes. Here it comes. The rock and roll. Oh. Wow. Okay. Excellent problem. Excellent problem. We'll call this the rock and roll problem, okay? Because I love rock and roll. All right, now. 200 meters, 10 meters. DI over DO. 200 over 10 is 20. 20 is the IMA. 5,000 newtons. That's my FO. The FI. The applied. I don't have it here anymore, but what I had was 500. 500 newtons was my FI. 5,000 over 500, 10. Efficiency, AMA over IMA. AMA over IMA. 0.5. Don't have to write 50. It's nonsensical. 0.5, everyone understands it. Don't write percentages. Now, what would the ideal input force be if the IMA is 20 and the AMA is 10? There's going to be friction involved here. So how much is the friction? Well, I don't have that on the board. But what I have is, how do you calculate the ideal input force? Well, this is the ideal equation. In other words, the output work equals the input work. FODO equals FIDI, right? So 5,000 times 10 equals FI. I'm looking for the ideal or the input force. I stands for input, not ideal. 200 is DI. That's what I'm looking for. Okay? 250 newtons. That's the ideal input force. Input force should be 250 newtons. How much friction? How much friction? So friction will equal, took me 500 newtons of applied force to push that box up. Ideally I should have been using 250. 500 minus 250. 250 newtons is my friction. You know, it's not too bad, really. It's not too bad. You see how complicated this could be? I could ask you, what's the coefficient of friction given an angle there? Could do that. Okay? See you next time. Oh.